Hello, welcome to the final video here with example 6. Example 6 is asking us to consider this function. So it's a rational function. I have a quotient. I have something divided by something. B, I don't know what number that is, but I know that it's not 0. B is a non-zero constant. Three situations. Can we find possible values of B such that the function has exactly one vertical asymptote? Excuse me. Well, remember, vertical asymptotes occur whenever whatever's in the denominator left over after I reduce everything, whatever makes that equal to 0. So let's start there. Can we factor and think about what could possibly reduce here? So if I factor the numerator, I'm going to get x plus 5. Let me zoom in a little bit. Maybe those scratches will go away. Or maybe not. Let's see. A little better. If I factor the top, it'll be x plus 5, x minus 4. And if I factor the bottom, since I could make this like a difference of squares. So this would be x minus square root of b, x plus square root of b. If you want to think of it that way, right? So the question is, can you find a value of b for which we could have only exactly one vertical asymptote? So I'm going to say, what if b is 25? If b is 25, the square root of 25 is 5, and I have x minus 5. And if b is 25, so if b is 25, this is 25, and this is 25. The square root of 25 is 5, and x plus 5. These will reduce, and then I'm just left with a vertical asymptote with whatever makes that equal to 0, right? So that's one way to think about it. Another way to think about it, maybe if that square root thing didn't make sense, go back over here. Do you see how b would have to be 25 so that when I factored it, that would be x plus 5, x minus 5, and then these could reduce out. Boink, boink. That could work. And then I only have one thing left over, which would be this in the denominator, and that would be where the vertical asymptote exists. B could also be the number, or I'll put 16, right? Because if b is 16, I have x squared minus 16, then these guys become x plus 4, x minus 4, and then the x minus 4 is reduced, and I'm only left with one factor, and that's where that one vertical asymptote is going to come from. So these are two possible answers. We only needed to find one, but that is two possible values of b. All right. So then what would it look like if I had two vertical asymptotes? Let's see. We already know that the numerator factors out to x plus 4, x plus 5, x minus 4. And if I'm going to do this, what value could we insert for b in order for no factors to cancel, and therefore I would have two vertical asymptotes? The reality is that there's an infinite number of b values. For example, b could be, what if b is 36? If b is 36, x squared minus 36 can be factored into x plus 6, x minus 6. Nothing's going to reduce. That means whatever's left over in the denominator is going to make vertical asymptotes. So the vertical asymptotes would be at 6 and negative 6, right? Or b could be negative 6. Or b could be, 100. And that means x plus 10, x minus 10. And again, nothing reduces. So I'm left with two factors in the denominator, and that's the two vertical asymptotes that we're going to get. For that matter, b doesn't have to be a perfect square, right? B could be 24, or let's make it even smaller. B could be 12, and then this is x plus the square root of 12 and x minus the square root of 12. Again, nothing's going to reduce. I'm left with two factors in the denominator, and they represent the two vertical asymptotes that exist. So the reality is that b could be any number that's positive except 16 and 25. Because if I pick 16 or 25, one of those factors in the numerator is going to reduce, and then I'm just left with one. But if b is any number other than 16 or 25, then we'll get two vertical asymptotes, right? So here's the tricky part. How do we get no vertical asymptotes? Hmm. Well, vertical asymptotes come from the denominator. So then the question is, when would it be impossible to make the denominator equal to 0, right? What x value would or what b value would I choose so that no x value could ever make that equal to 0? Because the whole idea is, like the examples that we said on number 2, when we said x squared and b was 100, that was because we could do this, right? I'm sorry. We could do this, and one of those, I would get two answers that would give me 0. But here, what kind of b value would never produce 0 in the denominator? Pause your video to think about that. We already know 25 and 16 are the only b values that will create 1. Any positive number other than 25 or 16 will produce 2. But what type of number will produce none? Pause and think, and then come back. What if b is a negative number? Then this would be x squared plus 4. Is that factorable? No. So nothing's going to reduce from the top. But more than that, can you think of a number that when you square it and add 4 will make the whole thing equal to 0? Well, no, that's impossible because any number squared will be positive, and if I add more to it, then it's never going to be equal to 0. So while this is an example of that, the reality is you can pick any b value that's negative, and any b value that's negative will produce an x squared plus something, which is impossible to solve, and therefore there will be no vertical asymptotes in the graph. You can use your calculator to confirm that all these examples actually do make one exact or two exact or no vertical asymptotes, but if you think about it, it's kind of not intuitive, but it certainly makes sense as to why some work and others don't.